Hi, good morning and welcome to today's class. Today's class we'll be talking about algebra. Algebra seems to be one of the topic that is an issue to most of our students. I just pray that at the end of this class, algebra will no longer be an issue to you, to the point that you can equally impact the knowledge on others who are still having issues on algebra. Algebra is one of the aspects of mathematics that has to do with letters and numbers, the unknowns. Okay, and we are going to be doing justice to algebra today. And the aspect of algebra we are going to be looking at is the expansion and factorization of algebraic expression. Let's look at the objective of today's class. That by the end of this chapter, you will be able to 1. Identify algebraic terms and perform basic operations involving directed algebraic terms. You should be able to identify them wherever you see them and also carry out the basic mathematical operations of addition, subtraction, multiplication and division. 2 says evaluate algebraic expressions by substitution. Okay, that is self-explanatory. 3, to expand algebraic expressions. 4, we'll learn how to factorize simple algebraic expressions. And 5, we'll also simplify algebraic expressions involving fractions. So let's look at algebraic term. What do we understand by algebraic term? From our new general mathematics or new concept mathematics, we said an algebraic term is a term that comprises the product of numbers and letters of the alphabet. For example, we say product of letters and numbers. That is, if I say 2 times a, product of two letters and numbers will give me 2a. So this is referred to as an algebraic term. Also, 1 times b can be said to be 1b, which I can write as b, and this is also said to be another algebraic term. Also, if you have 3 times c times a, this is going to give me 3ac, is also said to be an algebraic term. Also, 3 times 2 times let me say x, y, z can be simplified to be 6x, y, z. We can also look at negative numbers, negative directed numbers. Example, minus 4 times 2 being multiplied by a times b. This will also give us minus 8ab. So all these are referred to as algebraic terms. Now, what do we understand by algebraic expression? Algebraic expression. An algebraic expression can be said to be the addition of 2 or more algebraic terms. I just showed you algebraic terms. So by the time you begin to add up all these terms, what you get is referred to as algebraic expressions. For example, 2a plus 4b minus 8ab plus 16xyz. All these are referred to this, the group of this, the sum of all this is referred to as an algebraic term. We also have 3x plus 2y is said to be an algebraic term. 4p minus 3q plus r also can be referred to as an algebraic term. So I have made mention of two things: algebraic term and algebraic expression. Algebraic term is the product of numbers and letters, while algebraic expression is the sum of two or more algebraic terms. So when you do that, you are going to have algebraic expression. Let's look at directed algebraic terms. Directed algebraic term. Now, we say like directed numbers. Directed algebraic terms have positive and negative signs associated with each of them. And when multiplying and dividing algebraic terms, the following rules are applied. When you have to multiply or you have to divide two or more algebraic terms together, these rules must apply. That is, minus times minus or minus divided by minus will always return a positive sign for you. Also, plus times or divided by plus will equally return a positive, while when you have minus times or divide by plus, is going to return a negative. Or when you have plus times or divide by minus, will always return a negative sign. Now the trick there is, if you look at the first two that return positive, you will discover that the two signs you are multiplying are of the same type. So when you multiply two signs that are same or divide, is going to return a positive. But when either of the two, as in the case of these two, they will always return a negative. So when they are of two different signs, they will always return what? A negative. So take that. So let's take some examples. Okay, let's take some examples that will simplify the following. A says minus 6 times minus 11. Remember what I told you on the multiplication rule, that when you are multiplying two negative signs, this becomes minus 6 times minus 11, which is equal to, I'll first of all multiply the signs. Minus times minus will return a positive because they are of same sign. Then I will also multiply the numbers 6 times 11, which will give me 66. So my answer is positive 66. While this will give us minus 4a to be multiplied by plus 7b. This is equal to, I'm going to multiply sign for sign, number for number, and letter for letter, and you see what we are going to get. Minus times plus will give me minus 4 times 7 is 28, and a times b will give you ab. So minus 4a times plus 7b will return minus 7ab. Number 3 says plus 3b times minus 9. This is going to be plus 3b times minus 9. Also, we multiply sign for sign. Minus times minus. Plus times minus is minus. 3 times 9 is 27, while we have b. This will also give me plus 28 divided by plus 4. Okay, plus divided by plus is plus. 28 divided by 4 is 7. So I'm having positive 7. Also, plus 48 divided by minus 16. This can also be written as a fraction as plus 48 divided by minus 16. And when you divide, plus divided by minus is minus. 48 divided by 16 is 3, but let's see, 2 into 16 is 8, 2 into 4 is 2, 2 into 8 is 4. What can also divide? 2 can divide. 2 into 8 is 4, 2 into 2 is 1, into 4 is 2. So this becomes 12 divided by 4, and 4 into itself is 1, 4 into 3 into 12 is 3. So this is returning a negative 3 as our answer. And the last example says 6a times minus 5b divided by minus 2. Here we are going to obey the Bodmer's rule, which says bracket of division, multiplication and addition. We are having multiplication and division operations, so which comes first is that of the division. So I'm going to divide before I will multiply, meaning I'm going to carry out this operation before I will multiply with 6a. So this is going to be 6a times, this is minus 5b divided by minus 2. So that this is going to give me 6a times minus is going to be minus divided by minus, is going to be positive. So I may decide not to show the sign, or I may decide to write positive 5b over 2. And when you multiply it with 6a, you agree with me that this becomes 6a times 5b. 6 times 5 is 30. A times b is ab. All divided by 1 times 2 is 2. And you divide and discover that 2 can divide both itself and 30. 2 into itself is 1. 2 into 30 is 15. So that our final answer becomes 15ab. You may want to ask, where is the sign? Why is the positive not there? Whenever your sign is positive, you may decide not to write positive, or you may choose to write positive. But if it is negative, the negative sign must be there to show that it is a negative. So you can either leave it this way, or you write it as positive 15 AB. So we are going to be solving more examples on exercise 10.2, which says we should simplify each of the following. And the first one says 2 times 3x, which is equal to 2 times 3 is 6x. Number 2 says positive 3 to be multiplied by negative 2x, and this is going to give us, this will be equal to positive times negative is negative 6x. Number 3 says minus 5 times 3f, which is equal to, this is positive, so negative times positive is negative 15f. Number 4 is positive 7 to be multiplied by minus 4m, which will give us this will be minus 28m. Number 5, positive 4 times positive 2r, which is equal to positive 8r. Number 6 is plus 5 to be multiplied by minus 3p, which will give us minus 15p when you multiply. Number 7 is minus 4 to be multiplied by minus 6a. This is going to give us negative times negative is positive 24a. Number 8 says minus 3 times minus 4q. This is equal to positive 12q. Number 9 says minus 4 times positive 7q. This is equal to negative 28q. And number 10 says 5b times minus 8, which will be equal to minus 40b. 11, we have it to be 8n divided by 4, which is equal to, can also be written as 8n divided by 4, which is equal to 4 into itself is 1, 4 into 8 is 2n. Number 12, you have 12a divided by 8, which can also be written as 12a divided by 8, which will be equal to, what can divide? Reduce it to in simplest form. You discover that 4 can go into 8 2 times. 4 into 12 is 3. So this is going to give us 3a over 2, which is a fraction. Number 13 says minus 25n, I beg your pardon, divided by 8. This can also be written, the division sign, this can also be written as minus 25n divided by 8, and is also in a fractional form. Number 14 says 81a divided by 45. Expressing it as a fraction gives us 81a divided by 45. Look for the common factor that can divide both 81 and 45. That will be 9. 9 here is 5, and 9 into 81 is 9, leaving us with 9a divided by 5 as your answer. Number 15 says 112m divided by 4. Is this a multiple of 4? Okay, let's see. Can 4 divide? Let's start with 2. 2 into 4 is 2. 2 into 11 is 5, remainder 1. 2 into 12 is 6. So this becomes 56n divided by 2, but 2 can still go. 2 into itself is 1. 2 into 5 is 2 remainder 1. 2 into 18 is 16 is 8. So therefore our answer becomes 28n. Okay. Next is question number 16. And question 16 says 2x times 3y times 4z. This can be said to be 2x times 3y times 4z. Just like we did, multiply the signs, thereafter multiply the numbers and then the letters. But if you look at it, they are all positive, so they are going to return a positive sign, because positive times positive is positive, and positive times another positive returns positive. Also 2 times 3 is 6. 6 times 4 is 28. X times y is xy. Xy times z is xyz as your answer. Number 17. Saying 6p times minus 5q to be multiplied by 2r, and this is going to give us same as 6p times minus 5q times 2r, which is equal to plus times minus is minus, times plus is minus. So this is going to give us minus 6 times 5 is 30 times 2r, sorry, not to write that now. So this is going to be minus 6 times 5 is 30. 30 times 2 is 60. P times Q times R is going to give us PQR as our answer. Number 18 says 3a squared b to be multiplied by 4ab. This is equal to 3 times 4 is 12. A squared times a will give us a cubed. B times b will give you b squared as your answer. Number 19 says 12a squared b cubed to be multiplied by 9ab squared divided by 4a cubed times 3b raised to power 4. This can be simplified to the, I'll first of all solve what we have at the numerator before the denominator, or I can go straight ahead to reduce them to the lowest thing before I simplify out. So this is a cubed. Okay, let me simplify out. This becomes I can call it 12 times 9 for the numbers, the times later a squared times a will give us a cubed and b raised to power 5 divided by 4 times 3 is 12 times a cubed b raised to power 4. 12 can cancel out 12. A cubed can divide a cubed, leaving us with 9. Okay, b can also divide. This is b raised to power 5. 4 of this will divide 4 of this remaining 1. So this is going to be 9b as our answer. Number 20, this is going to be 6a squared bq times 4ab squared to be divided by 8a cubed b cubed, so that this is equal to, do same and divide, b cubed will divide b cubed. This is a squared will divide 2 of them here, while this, the last one, is going to divide this. 4 into itself is 1, 4 into 8 is 2, 2 into itself is 1, and 2 into 6 is 3, leaving us with 3b squared as the answer. Also, number 21 says 11xy squared divided by 26z cubed of 130z squared y divided by 33zx of, we are told, is what? Multiplication. So this can also be simplified to be 11xy squared divided by 26z cubed times 130z squared y divided by 33zx. So I can go straight ahead to simplify them. X will cancel x. This is z and this is z squared. So this z will cancel one of this, leaving us with 1. So this will cancel one of this, leaving us with 2. So that our answer now becomes, I'll now multiply 11 times, it becomes 11 times 13 into y cubed. Okay, this is 130. 11 times 130 divided by 26 times 33 times z squared, and this is equal to 11 into itself is 1, 11 into 33 is 3 times. Okay, can 3 divide? No, 3 cannot divide this. Okay, 2 can divide 26, 13 times 2 into 13 is 6 remainder 1 into 10 is 5. What else can divide? I think 13 should be able to divide less. 13 into itself is 1. 13 into 65 is 5 times. So that my answer now becomes 5y cubed divided by, this is 1 times 3 times z squared, becomes 3z squared as your answer. 22, which happens to be the last question on this exercise, no? Says minus 11 110 AB divided by minus 11A. This is equal to, you can write it as a fraction, minus 11 110 AB divided by minus 11A. Minus will cancel minus, leaving us with plus, so that 11 into itself is 1, 11 into here is 1, into 0 is 0, a will cancel out, leaving us with 10b as our answer. Let's look at question number 23. 23 says 3a divided by 8b times 18b squared divided by 9a squared, so that this can be simplified to be equal to, I can simplify this out, this is 3a, it becomes 3 times 18 into a times b squared divided by 8 times 9 into b times a squared. So 9 into itself is 1, 9 into 18 is 6, sorry, is 2, 2 into itself is 1, 2 into 8 is 4. One of these b will cancel one of the b's, that becomes b squared divided by b is b, a into a squared is a, so that this now becomes, at the numerator we have 3b divided by, at the denominator we have 4a. So this is your answer. Question number 24, which happens to be the last question, says minus 3 over 8 of ab divided by minus 3, which is same as minus 3 over 8 times ab divided by minus 3. Minus 3 will cancel itself, and our answer becomes ab divided by 8. Kindly go through the questions on exercise 10.2 of your new concept mathematics to see how well you can solve, and thereafter compare it with what I have done. Whichever you couldn't solve, you can come back and rewatch the lesson so as to be able to solve them. You can also do some exercises from your new general mathematics, and you will discover that your problems would have been solved halfway. So I would like us to stop at this point for today's class. Subsequently, we'll continue with other aspects of algebra. For today, we have been able to deal precisely with I think the first objective, which says identify algebraic terms and perform basic operations involving directed algebraic terms. That we have done, and also we were able to, we have been able to solve that. In our next class, we will try to evaluate algebraic expression by substitution. Thank you very much for being attentive in today's class. I hope you have learned something new. For your questions and comments, you can just send it through the comment box behind under, and you'll be very much assured that we'll get back to you to attend to all your questions. Before you check out, ensure that you have subscribed to this channel so that you'll be updated as we upload more videos on lessons on mathematics and other subjects. Thank you very much and have a nice day.